Let's discuss this question: minimum number of removals to make mountain array. So basically, we are given one array and we need to convert it into mountain array, and we need to find what is the minimum number of removals that we need to do. Now what's an mountain array? So mountain array is nothing. Basically, first we will see a strictly increasing sequence, and next we should see a strictly decreasing sequence. So like 1 2 3 4 5, again like 3 2 1. So this is a kind of mountain array. So we need to find out what is the minimum possible, or basically what is the minimum number of elements we need to remove to make it a mountain array. Now how we can do this actually? So one possible way of opening mountain array through recursion actually. So basically we are suppose we are given this array. What we can do, we can actually each of the element we can actually take a decision, basically take or no take. Basically we can form every or all the subsequence of this array and run a for loop from starting to end to see whether it's a mountain array or not. If we find that it's a mountain array, then we don't do the recursive call. But in the limit it is told that n, or the number of element, is 1000. So we in the recursive call we will end up having 2 to the power 1000, which is not feasible actually. So this provokes us to think of a dynamic programming approach. Now if we try to solve this recursion problem with basically take and no take and try to put it in dynamic, we will see so there is no uh, like uh, s- uh, like it basically does not qualify for DP in this way. Now how we can solve this? Basically the basic, or how we can solve it, let's see. So basically suppose we are given this array and we can easily uh, identify that a mountain can only be in this range. Like we cannot have a peak over here and we also cannot have a peak over here. It can only be in this range. So what we will do, we will start from here or at this location and we'll go up to here, trying to find trying to figure out uh, what is the increasing sequence actually, or like what is the maximum number of element with which if this is the peak. So for one we can see the peak. So this element, when we are trying to pick from left to right, is 0. Now we can form a peak with this element only if this element is greater. So can we form a peak? No, we'll put 0. Again 1. 1 should be greater than either 1 or 2. Can we form a peak? No. 5. We For 5 we can see that with 2 it can form a peak. Like it can be 2 5, it can be 1 5, and again it can be 1 5. So we take what's the value over here, uh, what's the peak value over here, which is 0, and we add 1 to it. So 0 plus 1, 1. Now if we come to 6, right? So with 6 we can form mountain with 2, with mountain with 1, we can form mountain with again 1 and again with 5. But we need to figure out what's the maximum among these. What's the maximum? Maximum is 1. We'll take 1 and add 1 to it, and this is the result. Similarly for 2, what are the possible candidates? These two actually. So again it's basically 1. For 3, what's the possible candidate? We can either take 2 or any of these ones, or these two. Again it's 2 actually, right? Sorry, it's 1 actually, right? Because yeah, it's 1, like the size of the mountain is 1. Now again we do the same thing while traversing from right to left. We do the same thing while traversing from right to left. So this will always be 0. Let me just form the array. So this element should be greater than the next elements. So basically 3 is greater than 1. Yeah. So we will take this plus 1, which is 1. This plus 1. 2. 2 is greater than 3. We can't take it. 2 is greater than 1. Yeah, we can take it. So it's again 1. 6. 6 is greater than 2. Yeah. 6 is greater than 3. Yeah. 6 is greater than 1. So 2's peak value is 1, 3's peak value is 1, and 1's peak value is 0. So we can take any of this maximum, which is 2. Now if we think of 5, uh, now if we can think of 5, we can again take 2 or 3. It's also 2. 1, we can't take any, it is 0, it's 0, and 2, which is again 1. Now what's the maximum actually? So 1 goes to here, 3 goes to here, 2 goes to here, and so actually this is the case actually. So for 6 it's 2. Let me try to, so we have 1 2 3 4 5 6 7 8. We have 1 2 3 4 5 6 7 8. So 1 goes to here, 3 goes to here, 2 goes to here, 6 goes to 2, right? Now similarly 5 goes to here, 1 goes to 1, like this. Similarly, if we just rewrite this array, 2 1 1 5 6 2 3 1, right? So maximum we can see it's happening for 2. So the maximum array or the maximum length of the array which gives us a mountain array is 4, right? And is it 4? No, it's not 4 actually. So it's 2 plus 2 plus 1. Why 1? Because we need to calculate the, or we need to take the peak element as well, which is 1. So the maximum uh, value is, or the maximum length of the mountain array is 5. And what was the original length? 8. So it's 8 minus 5 equals to 3. So we need to remove 3 elements to make it actually mountain array. Now let's look at the code for better understanding. First we create two arrays basically, from this is for traversing from left to right, and this one is from right to left, right? So we go from 1 to n. So as you mentioned, 0 will always, like 0th index peak value will always be 0. So we are just putting at 0, and we just go from 0 to uh, I minus 1 to figure out the maximum value, and we put it and we update it, and we update the left to right max value here, if and only if we get at least one value which is less than the current index. So suppose we have this, again we have this array dot 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 dot. So for this one we will not update because we didn't hit this flag. So this, the we'll never go inside this if block. So this is crossed. Again for this is crossed. But for 5 we are going to update it. The reason being that we got at least one element, at least one element, at least one element which are less than this one. So we are going to set the flag to true, and we are going to update the value of maximum of these three, which is 0 0 0. So it's 0 plus 1. But for 1 we are not going to do 0 plus 1 because we didn't get any element which is less than 1. Similar thing we do while traversing from right to left. This element will always be 0. We try to see for every index we go over, we start from here and go over here, go up to here. So all this loop are order of n square actually. Now we look at the peak values possible. Suppose we have this array, we exclude these two because these two can never be the peak, because peak needs to be in middle. So we need to look only at this element. So we need to neglect the zeroth element and the n minus 1, whatever we got, and we uh, try to find out the maximum among this, if and only if at least we got at least its peak from both the end. It should not be that it's peak from left and it's peak from right. We cannot take it. It should be peak from both. At least we should have one element which is greater than this one actually, which is greater than the value which is present at ith index. Then only we can take it. So that's why we have this condition, and we go over iteratively over this max and left to right and right to left max to figure out what's the maximum. And as we need to also get a hold of the peak element, so we are also adding -1. So n minus result -1. So that's the result, and that's a value that we just return. Thank you.